Hey guys, it's Mr. Grady. Just want to remind you, if you have not already, get on YouTube, subscribe to our CMA 8th grade math channel. We post a lot of good information. Remember that our lessons from previous days, so you can see up here, will be posted on there. We also do the spiral math questions for the day, so you want to get those up there. Also, this is really cool, Mr. Shog put up a really good lesson about finding slope when you're given 2 points, which we're going to get to today. This was a preview lesson that he talked about the other day, and if you wrote this down over the weekend, took notes, and brought it into us, you got some extra credit. So if you missed this opportunity, subscribe to our channel and you'll be able to see it on the weekends when we put a preview question up. Okay? Tell your friends, tell your family. It's that awesome. All right, so let's get to our learning for today. So what are we going to learn today? First of all, we're going to learn how to calculate the slope or the rate of change from information provided in a table. Remember, we already know from previous lessons that slope and rate of change are the exact same. They mean the same thing. Okay? Why are we learning this? We're learning this so that we can deepen our understanding of slope. So we already know how to do slope from a graph. We talked about that. We took a test or a quiz over that last week. Now we're just going to deepen it and look at it in a table. How will we know if we successfully learn this? So how can you tell at the end of class if you've got it? Here's how. If you can explain. Now remember, explain means written form. You are writing a paragraph, a summary, a couple sentences explaining how to find the rate of change when given a table. So at the end of our lesson, there's going to be a closing question. You're going to have to explain. If you can do that, you'll successfully know what we're talking about. All right, so here is our lesson for today. We are starting activity 2.2. We're on page M297, so I'm going to give you a second to get there. While you are flipping to M297, just a little preview. We will be jumping around in chapter 2 or section 2 a little bit. So you want to have your whole book handy or all your pages handy. Okay, so hopefully you've had a chance now to get to page M297. Up at the top we have some directions. We're going to read through those together. I know my screen's pretty small. I'm going to zoom in on the table and the questions when we actually get to those, but I want you to be able to see the directions. So when I stop, we're all following along. We are all reading the next word. Remember, all means all, everybody reading. Okay, here we go. So far, you have the rate of change from A using similar triangles and writing a ratio of the distance to the horizontal distance. However, you can also the rate of change or slope from A. All right, so let's zoom in here for a second. So if we look at this, we've been given a table. Remember, we've already found rate of change, slope from a graph. It already gave us that in the directions. But let's talk about this table for a second. So let's talk about a few things. First of all, anytime we have a table, our first side, our left side of the table, is going to represent our x values. So go ahead and mark that on your table. The left side is our x's. Now the x's, as we learned before, are the independent variable. Okay, so write IND to remind us it is independent. So if the left is the x's, that means the right has to be our y values. Now remember, the y's are the dependent variable because it depends on what the x is. So the x value kind of changes the y when we get into equations, which is why the y is the dependent variable, because it depends on the x. Now with that said, let's look through these questions here. So A says to choose any two values of the independent variable and calculate their difference. Now we're going to be overachievers here because that's how awesome we are. And we're going to find the difference from every independent value. So as we're looking at the x values, we're going to find the differences in them. Now remember, difference, we know this word. Difference means subtraction. So we're going to be doing some subtraction to find this. So all it's asking us to find is the difference between 0 and 12, between 12 and 18, 18 and 25, and 25 and 40. Again, difference is subtraction, so we're just kind of working backwards. So let's start with our first pair, 0 and 12. So we're just subtracting 12 minus 0, which gives us 12. Okay? Move to our next one. We're doing 18 minus 12. 18 minus 12 is 6, so that's our difference. So I'm going to give you about 10 seconds to finish up this table finding the differences on the left independent side. All right, now we're all going to share our answers together as a class. So on the count of 3, you're going to tell me the difference between 25 and 18. On 3. Here we go. 1, 2, 3. Okay, so hopefully we got it. 25 minus 18 is 7. Let's try this again. We're going to do the same thing for 40 minus 25. On 3, we're all saying the answer. 1, 2, 3. Okay, so we should have had the answer of 15. Let's go down to question B. B reads, calculate the difference between the corresponding values of the dependent variable. Now remember, we know the dependent variable, that's representing our y's, because they depend on the x's. So if we continue, it is important that the order of values you use for determining the difference of the independent variables be followed. Okay, so all that's saying is we need to go in the same order. So I'm going to give you about 30 seconds here, and I want you to find all of the differences for our y values, or the dependent variable. Go ahead and start. All right, guys, our time is up, so let's check our answers here. So we'll do a couple where I just say the answer, and then we'll share some together as a group. So our first amount that we were finding the difference, 216 to 120, we should have had 96 as our difference. Our second difference from 264 to 216 should have been 48. Okay, so now we're going to share out together. So we're all on the count of 3 going to say the difference from 320 to 264. So on the count of 3, we're all saying our answer. Ready? 1, 2, 3. Okay, we should have had 56. And then our final difference on 3, again, we're going to say this as a class on 3. 1, 2, 3. Okay, we should have had 120 as our difference between 440 and 320. All right, so let's look down now at C. Here's where it gets good. So down at C, and when I stop, you're reading the next word, so everybody following along, because there's a word I want you to see in here. So you guys are going to be saying a very important word. So you're following along on C. Here we go. Write a rate to compare in the dependent variable to in the independent variable. Now you guys had to say this word right here, change. Put a box around change. Put a box around change. Okay? Now the other thing I want you to point out is this word rate. We've used this word rate as a ratio. Now again, from what we already know, a ratio is a fraction. So basically what they're asking us to write is a fraction that shows the change in the dependent variable. Remember, the dependent variable is our y, so we're just marking the text a little bit here, to the change in the independent variable, which is our x. Now, if you remember all the way back to when we first took Cornell notes over slope, we talked about another name for slope, besides slope and besides rate of change, is the change in y over the change in x. So I want you to write this out to the side just to remind us. So we've already talked about it, so we're going to write it to the left. So it's the change in y over the change in x. Now when we say the word change, what we're saying is that we're going to be doing some subtraction. It's basically like the difference. Now we've already found that difference up here in our table. So we're just taking the amounts that we've subtracted to get from our table and putting them into a fraction form. Okay? Remember, slope is always, always, always y over x. So we want to keep that. So we're going to write a rate for every single thing that we've done. Now, if you remember back to B, it was very specific that we have to use corresponding. So what that means is if you'll look back up to the table, you have to use the amounts that are directly across from each other. So I'm circling these amounts that are across from each other just so we know which ones we're using. So I'm going to make the first rate. You're going to do the other 3. So our first one, remember, is y over x. Our first y value was 96. So I have 96. That was our first change in y when we subtracted, over the change in x, which is 12. So there's our first rate. Now I want you to leave some space next to this, and you're going to have our second rate, our third rate, and our fourth rate. So go ahead and do that. I'm going to give you 30 seconds. Go. Okay, so let's look at our second rate. So you're looking at the second rate that you made, okay? We're all going to say that on 3. So remember, it's something over something. That's how we're saying this. So you're looking at your second rate that you made, and we're going to say this all as a class on 3. Everybody participating. Ready? 1, 2, 3. Okay, so we should have had 48 over 6. Now for your last two, I'm going to have you partner share. Partner 1, you're going to say the next rate that you made. Then partner 2, you're going to say the last rate. So 1s have the third rate, 2s have the last rate. Go ahead and start. All right, so that should have been short and sweet. Our third rate should have been 56 over 7. And our final rate should have been 120 over 15. Okay? Now, let's look at D for a second, and then we're going to do one other thing with these rates. So D says to rewrite the rate as a unit rate. Okay, I want you to box that unit rate. What unit rate means is we want to basically reduce these fractions to get 1 in the denominator. So we want something over 1 for our answer. So you've got to do some reducing here. So I'm going to give you another minute. I want you to go back and you're going to reduce all these fractions down and see if you can make them something over 1. Ready? Begin. Okay, the next step I would like for you to do, so hopefully you have your unit rates for all of these. The next step I would like is for you to share, so you're going to partner share for a second, anything you notice about all of these rates. So I'm going to give you about 10 seconds. Just share with your partner anything you notice about all of these unit rates. Go. All right, so hopefully we came to the conclusion that every one of these unit rates reduces to 8 over 1. So all of these can reduce to 8 over 1. So what that tells us about our table is that our slope, or our rate of change, is 8 over 1. So I want you to go back down here and circle all of these fractions. So up at the top, let's write this just so we kind of have a conclusion here, that our rate of change, okay, now remember that's the slope that we're trying to find, was 8 over 1 for our table. All right, you guys have done an excellent job. Like I said, we're going to skip around. I want you to flip forward in your book to page M2 100. So I'm going to meet you at M2 100. Here's what M2 100 looks like. I will go ahead and zoom in here in a second as we go through some of this, but let's look up at the top at the directions. So it says you can now use the slope formula to calculate the slope of a line given a table of values. Remember, the slope formula is the change in y over change in x. So we're going to use that as we figure this out. So I'm going to zoom in a little bit. Here's what our tables actually look like. Remember that we want to use that formula. So over to the left, I want you to write that out. So we're using the change in y over the change in x. Okay, so remember, change is just the difference. We're subtracting. Okay, so we're just subtracting the difference. So one says calculate the slope. for each linear relationship using the formula. Show all of your work. So we're going to do one more together, and then I'm just going to give you time to work on the remainder of them. So let's look at A. Remember, in our table, x's are always on the left, y values are going to be on the right. So we're just looking for the difference. Now, we went ahead and found all of the differences before. Truly all we need to find in this case is the difference between two numbers. So let's pick any two numbers. So I'm going to use 16 and 8. So I need to find the difference between 16 and 8. So I'll subtract that. So I'm going to subtract 16 minus 8, which gives me 8. Remember, I need to use the exact same numbers across from 16 and 8. So I'm going to use 18 and 12. So I need to find that difference. So I'm going to subtract 18 minus 12. So you're subtracting 18 minus 12, and on 3, we're all going to say what 18 minus 12 is. Here we go. 1, 2, 3. Very good. You should have said 6. So we have 6. Remember, when we write slope, it's y over x. So we're going to have 6 over 8 as our initial fraction, or our rate of change. We're going to reduce that, though. Remember, anytime we have even numbers, we can always divide by 2. So we're going to divide both of these numbers by 2, which is going to leave us with 6 divided by 2 is 3, and 8 divided by 2 is 4. So our actual rate of change, or our slope, is 3/4. Now you're going to do questions B, C, and D. If you look down at E, E and F have given you the ordered pairs already, but it's just like if it was in a table. Okay? So you need to, first of all, mark some things. On E, we have 10, 25. In an ordered pair, remember, X always comes first, Y always comes second. Same thing over here. X always comes first, Y always comes second. Now, if you were somebody who was super prepared and watched Mr. Schrog's extra credit video over the weekend, this is the type of question that he was looking at. So you actually are going to put some numbers by these two. So our first x value, 10, gets a 1 by it. Our second x value gets a 2 by it. Our first y value gets a 1 by it, and our second y value gets a 2 by it. And that just helps us order things, because remember, we're subtracting the difference of our y's. So when we do this, we're using y2 minus y1. We're just finding the difference. And x2 minus x1. So again, just finding the differences in the x's. So I'm going to set my timer over here for 3 minutes, and in 3 minutes we're going to go over our answers for these tables. Okay, guys, our time is up. So here's what I would like for you to do next. Partner 1, you are going to share your answers for the rest of the tables. So partner 1 has the rest of the tables. You're just talking about your answer. Then partner 2, you're going to share your answers for E and F, where they just gave you the 2 points. So partner 1 has the rest of the tables. Partner 2, E and F, ready and begin. Okay, guys, so let's go over our answers here real fast. So for B, we should have had negative 15 over 1 for our answer for the slope. For C, we should have had positive 2 over positive 1 for our slope. For question D, it was a little bit different because we had all these 9s that were the same. This is 0 over 11. Now, we have actually talked about this, but we're not going to go into detail of it right now. But you will get to a chance where we talk about what it means when there's 0 in our slope. Let's look at E. E should have been 1/3, or 1 over 3 for our slope. And then F should have been negative 4 over positive 5. So hopefully these are answers that we got. So what I'd like for you to do now, remember we're kind of skipping around a little bit, is we're going to flip over to page 102. So I'm going to move mine. You're flipping over to page 102. Alright guys, so we are on page 102. Now all I've done is zoomed in on the table there. So we've jumped ahead to section 2.4, which is determining if a relationship is linear. Now our directions are going to add one other bit to this that we didn't have before. So we're going to read through question 1. We're in the middle of the page. When I stop, you're reading the next word. Okay, here we go. So it says, calculate the between the given ordered pairs to determine if they form a line. Show your work. So here's what I would like for you to do. Underline where it says straight line. Okay, so I know we've talked about this before, and at least in my class, but a linear relationship, remember that's what the title talks about in this section. A linear relationship means that our table or our graph or our information represents a straight line. So when you see the word linear, it kind of has the word line in it. Linear, straight line, has line in it. Okay. So the first step to this is exactly what we've been doing. You're going to calculate the slope. You're going to actually need to calculate the slope for every single point. So you're going to find the difference for all of the points. So you're finding the difference from 4 to 9, 11 to 9, 16 to 11. When you're coming over here, and you're going to find the difference between 28 and 13, 34 and 28, and 47 and 34. So I'm going to give you 30 seconds to find those differences. Go ahead and start. All right, so hopefully you've had a chance to find all the differences. Partner 1, you're going to say all of our x value differences. Partner 2 is going to say all of our y values, and then we'll be ready to go. So starting with partner 1, saying all the x differences. Go ahead and begin. Okay. Okay, so let's compare what we got. So 9 minus 4, the difference would be 5. 11 minus 9, the difference would be 2. And 16 minus 11, the difference would be 5. Let's look over here now at our y values. The difference between 28 and 13 should be 15. The difference between 34 and 28 should be 6. And then finally, the difference between 47 and 34 should be 13. Okay? Now remember, to determine what the slope is, we have to make these into ratios or rates. Remember, we always have y over x. So we just found the change of the y's and the change of the x's, and that's what we're making into our fractions. So I'm going to give you a second. I want you to use our numbers that we just figured out for the differences and make these into our unit rates, or our rates, sorry, of change, and write this out to the side. So you're writing your answers over to the left. All right, so let's see how we did. So our first rate of change, or our slope, should have given us 15 over 5. Now we know that we always want to reduce, and we can divide both these numbers by 5, which would have left us with 3 over 1. So our slope is actually 3 over 1. Let's look at our second amount. So we started with 6 over 2. Again, we can reduce, and that reduces down to 3 over 1. So far it's looking pretty normal like what we've seen. Let's look at the last section. So we have 13 over 5. Well, that's kind of weird because we know we can't reduce 13 over 5. So that means our slope is 13 over 5. Now here's where we go back to our question. We were supposed to determine if they form a straight line. Anytime we have different slopes, so we had 3 over 1, 3 over 1, and 13 over 5. Anytime they're not all the same, that means this is not going to form a straight line. Now we've talked about it as a linear relationship up above, so instead of saying not a straight line, we're going to talk like math people would talk, and we're going to say this is a non-linear, because remember, linear means straight line, so this is a non-linear relationship. Okay, so again, if our slopes that we come up with are not all congruent, the exact same, that means this is a non-linear relationship. Okay, so I want you to skip forward now. You're going to look to the very next page. So look on page 103. So you're going to skip to page 103. Okay, so here's 103. On page 103, I want you to do tables A and B, and you're going to tell me if it's a straight line or not. Now remember, instead of using the word straight line, we're going to say either linear or nonlinear. All right, go ahead and work. Okay, so let's share our answers. We're either going to say linear or nonlinear. So let's look at table A. Think about what you're going to say, and on 3, we're all going to say our answers. So remember, if all the slopes are the same, it's linear. If they're not all the same, nonlinear. So on 3, we're going to say our answer for A. Ready? 1, 2, 3. Okay, we should have said nonlinear. So not all the slopes are identical or congruent. Let's look at B. On 3, we're all going to say our answer for B, either linear or nonlinear. Ready? 1, 2, 3. Very good. We should have said linear for this table. All right, so if you remember back to our original learning goals for this class, we talked about that to be successful, we would have to do some explaining at the end. So now that time has come. So here's what you're going to explain. So your teacher's going to give you a half sheet of paper, and you're going to have to do a little bit of writing. So you're going to explain how to calculate the slope when you're given a table. So you're just summarizing, putting into words what we've been doing. I gave you some vocabulary words down below, and I want you to use as many of these words as you can think of. So it's just to get your head kind of brainstorming a little bit. You're going to use as many of these vocabulary words as you can think of in your explanation. Okay, ready? Begin.